Hello, so today we are going to do this problem called vertical order traversal of a binary tree. This is part of Leetcode September challenge. So the problem says we have a root of a binary tree and we want to calculate the vertical order traversal. And so for each node, row, column, its left and right children will be in position row +1, column -1. So it's a child below it, so the row needs to be incremented by 1, and it's to the left. Right, it's the left child, so it needs to be column -1. For the right, it's the same row, but to the right, so column +1. And the root starts out at 0, 0. So that's kind of the structure we are working with. And what we want is the vertical order traversal of the tree. So we want to do it top to bottom, and going from left to right for the columns, top to bottom for the rows, and left to right for the columns. Yeah, and if we have a value in the same position, so I think that may be the case if we had a right node here, right? Then we want to return the smallest one, and yeah, and at the end we want to return the vertical order traversal. So how do we do this? Row. This is the second row, this is the third row, and these are the columns: first column, second column, third column, and last column, right? And what we want is we want to return the column in a separate list, right? So if we take a look at the first column, there is only 9. It starts with 9. So we go for the rows from top to bottom. So we return a list of 9. For the second row, second column, sorry, it's like this. And so we do 3 and 15, right? Because those are in the same column. And notice here we start from 3 because 3 is the first row. And then for the second column, that's this one here. And so it's 20 only. And for the last one, it's just 7 only. The other way to kind of see this is that this has the column -1, and it's the only one, so we return 9. This has the column 0, and this has the column 0, so both get returned. And this has the column 1. So and it's the only one with column 1, so we return it. And this one has column 2, it's the only one, so we return it. And the columns like have negative indices, right? And yeah, so that's pretty much the problem. Now how do we solve it? You can see here the node value is not too big, and the nodes of the tree can be up to 1000, so not huge either. Okay, so how do we solve it? Well, the easiest way to think about doing this is that, so the numbers are not too big, the number of nodes, right? So the easiest way to think about it is, well, let's just fill a map, right, with the coordinates that we have here, right? So let's just fill a map with these coordinates. And what we are interested in is returning at the end a list for each column, right? So let's make the key a column so that it's easy to do this. And let's fill the, so basically we can have a map maybe called content, and the key would be column, right? And what should be the value? So for the value, it's the two other informations that we need. We need the row, right? We need the row, and we need the value itself, right? So that we return it in the list. So let's just add exactly those. So we need the row and we need the value, node value. Just make sure this is super clear. And once we do have this, and with this we can easily obtain it with DFS, because the thing is we start with a row with 0, 0, and if we go left we decrement by 1, if we go right we increment by 1. So we can easily do it with DFS. So fill content with DFS. Okay. And then the second step, once we have content, what should we do? Well, if we have content, the second step should be just going through it, right? But we need it in sorted order because we want the first column first. And so just sort contents first, right? Right, so since it's a map, we need dot items. And then for each, and then just add the rows into the list. So for each column, right, it would be a separate list. What we did here is each column has its separate list, which means here for each of these items we'll get like a column and a list of values. right? And so we just need to add to our result, we need to add the list of these node values here that we obtain from here, but in sorted order of rows. So we can just sort values again and then just add to our result, right? So it would be like something like this, where we want the sorted values and then we want the value. So we sort here so that we can get them in sorted order of the rows. We do this so that we can get them in sorted order of the rows, because row is the first index. And accidentally, like, this will also help us, where if the node value is the same, if the row is the same and the column is the same, we'll sort by node values, because it's the second part of the pair, right? Yeah, and that's pretty much it. So just fill content using DFS, and fill for each column, fill the row and node values, and then go through it and fill our result array, right? So that's pretty straightforward. So let's just implement it here. So we want a DFS on a node, and the node gets I and j, right? And then we know that we want to start out with the root, and the root starts out with 0 and 0, right? And then we get a result list that we want to return at the end, and then we will here use it. And then we want our content here that we will fill with DFS, so that's why we are making it a class variable here. And so it needs to be a map. And we want each column to have a list of rows, right? A list of row node value pairs. And so here, let's just default it to a list, so that initially it's for each key it's an empty list. And now we can do our DFS, and our base case for our DFS, if there is no node, we just return when we are at the end. And then we want to call DFS on the left side. So for left, the coordinate becomes I plus 1 and j minus 1. And for right, it's I plus 1, j plus 1, right? And so so this is for right. So we just apply that, which means here we would have I plus 1, j minus 1. And here we would have I plus 1, j plus 1 for the row, for the right side. And now we do the processing here, where self-content, we will need to, for j, for this column, right, which is j, we want to add this row and the node value. So we just append the row, which is position I, and the value, which is node.val. Right? And that's pretty much it for filling content. And now for the piece where we go through it and just add to fill res here, well, we just go through what we said here, we go through the sorted content items. And so let's do that. So this would be self.dot. And what we get the column and we get the values. Okay? And what we want to add to our result is the value for, so we get row and value in pair. But we said we want to sort it so that we can get the rows in sorted order. So let's just do that like this. And this is the list that we will add. So that this would be the list like this one here or this one here, like the list for each column. And so we want to add that to our result. And that should be it, right? So pretty straightforward here. Let's run it. Yeah, let's fix this syntax. Okay, so seems like there is a small issue here. So if not node, we want to return, so that's good. And here we append. Yeah, so the problem is we pass node each time. So for the left side, we want to pass left, and for the right side, we want to pass right. Okay, so that we get the proper value for these coordinates, right? So if we submit. Okay, so that passes test cases. Yeah, so pretty straightforward solution. Just fill content with the values and their coordinates, and then just traverse and fill the list according to the format the question asks us to do. Yeah, so that's pretty much it for this problem. Please like and subscribe, and see you on the next one. Bye.